Hi, this is Ms. Fitzmaurice, and this video is a solution to the problem on page 9 of your Unit 3 packet and number 10. Okay, so this is a hill problem. It says a skier slides down a slope with a 24-degree angle. Okay, so I know this is a hill because there's a slope and there's a 24-degree angle. I know that the skier has a mass of 72 kilograms and the coefficient of kinetic friction between the snow and the skis is 0.1. I want to know what is the skier's acceleration. Okay, so I have to draw a force body diagram. I know that gravity is pulling my skier down. I know that a normal force is pushing my skier up out of the hill, and that friction is going to oppose movement and it will be going up the hill. There's no applied force acting on the skier, so we're not going to have any applied force there. Okay, the other thing we have to note is that we are going to redefine our axes so that x is this way and y is this way. Okay, so the only thing we need to break up into x and y is FG. I'm going to redraw that diagram down here. Okay. And FGX will be mg times cosine 24. FGY will be mg sine 24. Okay, so of course the next thing we do, because this is a force problem, is we write out our Newton's second law equations. Sigma Fx equals max, and sigma Fy is equal to may. Okay, and now we look at our force body diagram and build these equations. In the x direction, we only have two forces. We have Fgx, okay, and that's going in the positive direction, so we have Fgx minus Ff, because that's going to the right, is equal to max. This is the acceleration we want to find at the end. Okay, and I can go ahead and fill it in. I know that Fgx is mg, and I screwed up here. Okay, this is opposite from the angle, so this will be mg sine theta, and this should be cosine because it's adjacent. Okay, so Fgx is mg times sine theta minus mu k times Fn is equal to max. Okay, going through this, I see that I have a number for all of these things except for a and Fn. So I probably need to use the y direction to find Fn. Okay, in the y direction, I have Fn minus Fgy is equal to 0, because there is no acceleration in the y direction. Okay, now I have Fn minus mg cosine theta is equal to 0, and I can solve for Fn as mg cosine theta. Okay, I'm going to take this mg cosine theta and I'm going to put it in for Fn over here. Okay, now I'm going to try to start, after I do that, I'm going to try to start putting numbers in, but not before. So I have mg sine theta, I'm just going to copy down what I had before, is equal to mu k times mg cosine theta is equal to max. Okay, finally at this point, I'm going to start putting in numbers. So I know that my m is 72 times 10 sine 24 minus 0.1 times 72 times 10 cosine 24 is equal to 72 times AX. Okay, at this point, I just have to do the calculations. So I know that 72 times 10 is 720 times sine of 24 will give you 292.9 minus 0.1 times 10 just gives you 1. So that's 72 times cosine 24, and you end up with 65.7 or 65.8, and that's equal to 72 times AX. Okay, so at this point you should all be able to solve for AX, and when you do, you should end up with AX is equal to 3.15 meters per second squared. Okay, so again, it's a force body diagram problem. The overall process is always going to be the same. We draw our picture, our force body diagram, we write out our Newton's second law equations, sigma Fx and sigma Fy. We try to fill them in, and we'll probably have to go back and forth between them in order to find a numerical answer at the end.